Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. Let's have a topic of mensuration. We know that there are four major areas in mensuration. That this mensuration consists of two parts. That's a two-dimensional mensuration, where we are supposed to deal with area and perimeter, and then we have second three-dimensional area that's related to where we are supposed to learn surface area and volume. Well, in two-dimensional mensuration we have different figures. You can see there's triangle, square, rectangle, trapezium, parallelogram, this kind of four figures including circle. And in three-dimensional pictures whose volume and surface area we need to learn, there are five numbers in your syllabus. These are five pictures: prism, pyramid, cylinder, sphere and cone. This is comparatively larger topic. Let's learn about area, my dear students, and the formulas related to area of different two-dimensional figures. And first of all is area of triangle. It's too simple. For you are very familiar that area is equal to half into base into height. And then area of quadrilateral, area of square, area of rectangle. And area of quadrilaterals actually consist of all the types of quadrilaterals, that is square, side multiplied by side, rectangle, length into breadth, parallelogram, length into height, trapezium, that's equal to half into sum of parallel sides into height. There are some other quadrilaterals as well. There's kite and rhombus. We have formula as area of those both figures is normally equal to half into product of their diagonals. And then the area of circle is the part of this two-dimensional setup, that the area is equal to pi r square, and then the area of the sector. This is a part of a circle that is not defined like quarter circle or semicircle, but this is any portion of the circle that has connection with the center of the circle. So its formula is x over 360 into pi r square, and the application is the area of shaded region, my dear students. Area of polygons, any polygon has area is equals to half into apotheme and the perimeter of the polygon. Area of shaded region is main application in two-dimensional mensuration. So let's have about perimeter as well. There are different formulas for perimeter. For the triangle, square, this is rectangle, then perimeter of quadrilateral, perimeter of any geometrical figure, sum of its all parts on the boundary, and the perimeter or circumference of circle, and then perimeter of shaded region. It's a sum of all measurements on the boundary of the shaded region. So first of all, look at area and perimeter with the length of arc and area of sector, my dear students. Let's have question number 1. Find area and circumference of a circle with a radius 14 centimeter. It's a so simple question. Obviously, you need to just mention what is the area, write on the formula, plug in the values. You will get first area pi r square, then circumference from 2 pi r. And then question number 2, find the area of a circle whose circumference is 52 pi. Give your answer in terms of pi. So write the formula for the circumference, that is 2 pi r, then substitute the values and lead your answer in the form of pi. And the next one, this is the solution, that is operated question number 2 to get the area of circle whose circumference was given. Now here we have a picture in which you can see there is a larger semicircle and 2 small circle. Question is, we are supposed to find the boundary of the shaded region, area of the shaded region, as well as boundary of the shaded region. So my dear students, let's see, find the area and perimeter of shaded region. So this is the way how we work. Area of larger semicircle with radius 14, this value is 308, and area of smaller semicircle, that is half pi r square, the radius is 7 and we got 77. Area of 2 small circles is equal to 2 times 77, because one small circle has area equal to 77. We will multiply it by 77 to get the area of 2 semicircles, and then area of shaded region would be equal to the focus in this question was to find the area of shaded region. What we will do, what we did actually, we found the area of the larger picture, larger semicircle, and then area of smaller circle. We added area of these 2 small semicircles, and we will subtract this from the larger semicircle to get the area of shaded region. Here we have another picture, my dear students. You can see here, this is a square in which 4 quarters are mentioned here with the radii. So first of all, we'll find the area of the whole figure. We are supposed to focus first. The area of whole figure is, because this is a square, that's 10 times 10. Then we will identify the rest of parts on this shaded region. So area of quarter circle is of 1 by 4 pi r square, obviously, and area of 4 quarter circle is equal to, we'll multiply 1 quarter with a 4, we will get the area which is outside shaded region, and now we will subtract this value from the total area, that was 100 times 10 times 10, that's equal to 100. So this is the way how to find area of shaded region, my dear students. And circumference of a quarter circle is equal to 1 by 4 into 2 pi r. Okay, then perimeter of any shaded region, we know in this question we need to find 2 things, perimeter and area. Area we have found first. Now the perimeter is equal to the boundary of this shaded region, and this boundary has different components. So a circular form has calculated separately again, and now perimeter of the shaded region is add up all the values on the boundary, we will get area and perimeter of shaded region. Well, in coming up questions, we will have length of arc and area of sector, and this is the question here. Find the area perimeter of a sector of circle, radius 14 centimeter, given that the angle at the center of the circle is this. It's a picture, my dear student, and it's a sector. First of all, we'll find the area of the sector, then perimeter of the sector. For area, we have formula x over 360 into 2 pi r, into pi r square, sorry, and then length of arc is angle at the center 144 over 360 times 2 pi r. So that will give us perimeter as well as area of the sector. Now we have another question. The figure shows a quadrant of a circle. This 90-degree angle shows that this is a quarter circle portion, and we need to work about this and find the area of the shaded region and the perimeter of the sector. Alright, area of the quarter circle is 1 by 4 pi r square. Plug in the value, simplify it, you will get 78.54. Now my dear students, area of triangle, we know half into 10 into 10, because this is a right angle triangle. So area of shaded region would be, just subtract this area of triangle from the total area of the sector. And we have another question number 3. In the given figure, O is the center of the circle. Let's have a picture. What picture is given? Here is picture, my dear students. Yes. And we have question that we need to find the length of the major arc. This is AB again, major arc, the area of the major sector. First of all, we're supposed to find the angle of the major sector. Radius is already given. Then with the help of angle at the center, we could be able to find the length of the major arc as well as area of the major arc. Let's have another question where we have given a leaf type shaded region whose area we are supposed to find. So simple. From the middle we know this is half cone, not cone, but in both situations when we have center one side, we will consider the whole cone, and if we have the opposite center, then we will have the area of both, but with both sectors, and we will subtract this from the area of the square. That will give us the area of the leaf. And now let's have another question. Calculate the area of shaded region of the given figure. Area of triangle ABC is equal to 25 centimeters square. Well, all the measurements are given. The area of triangle ABC is given 25, and the height AD is given, that's 5 centimeter, and you need to concentrate on component wise about this question. Area of semicircle with radius 5 and then followed by area of two semicircles. So they are not the semicircle, they are quarter circle according to the length of this triangle. And now the next one, my dear student. Well, area of the largest semicircle, there is two semicircles, even three semicircles, two small and one large, and a right angle triangle with its measurements. So first of all, area of largest semicircle, then area of the remaining largest, the second larger semicircle, and area of medium semicircle, area of smallest semicircle, area of two smaller circles. These are areas found from the given figure. With the help of the sides converted in radius, then we carry on for the solution of this equation, where we are supposed to find area of medium semicircle, and after that we need to find the area of shaded region. Just add up area of triangle and area of two semicircle area of two semicircle and triangle should be added, and the area of the largest semicircle whose radius is 25, that is also added. Then finally we are supposed to add up all these values. For area we are supposed to find components separately, so what we will do is we want to find shaded region. So area of shaded region would be equal to the total area of all the picture minus area of the larger semicircle. Well, the question is, find from the given figure area and arc length of the minor sector. My dear student, this is write the length of arc formula, plug in the value. 6 is the radius, x that we have in for the angle, so x is equal to 140, and we have given r, that is equal to 6. If you simplify, you got 14.7. Then area of sector is equal to x over 360 into r square. Let's substitute the values and carry on for calculation. Therefore the perimeter would be the sum of all possible sides. Well, this is another question about the sector where there is possibility that only major sector is under focus, but here is no restriction. You can use the angle directly 150 and carry on your work. So let's see the next one. We have a circle, my dear student. This is so simple while using angle or side of the circle, and I want to carry on. For this is one of typical question, very important, you can say, among the easy question of first easy questions of your paper 2. But most of your topic ask where our examiner when pick the question and ask the question by myself. Well, here is, my dear students, find the shaded area and perimeter of the shaded region when radius small r is equal to this, m is equal to 45 degree angle, and r is the 20 centimeter. Again it's the same scenario that we will find both area of sector with radius 10 and area of sector with radius 20. Then for shaded region we will subtract, and the length of the largest sector is equal to this. And let's have another question, my dear student. Here question is, in this figure the length of the minor arc is 7 by 24 of the circumference. So the circle, we write this condition here, the length of arc is this, we know, but the question is you need to find the exact value for this formula. You need to have radius, which is I don't think is given, but the circumference of the circle is given, from where we can find radius and then carry on for the rest of procedure. Well, the remaining part of the question is still continue, and